So in this video, we're going to cover 2.1 rectangular coordinate systems and graphs. So we'll review plotting coordinate pairs, looking at the quadrants and how they're labeled. In your book, again, I really encourage you to read through that, even if you're just kind of going through it quickly, just to refresh on some of the vocabulary and such. You'll notice that in the videos, I'm not going to cover the distance formula right now. I may save that for later when we're doing some applications. I'll just make a separate video regarding that. Midpoint formula we do not use very much, but the distance formula is going to be helpful at times, but you really can just do it using the Pythagorean theorem. So in figure 1, there's an application problem with the grid, and there's some other figures that you might want to check out. So now if you want to follow along with your video companion worksheet that I posted with the examples and try it problems that I do with the videos, there's also try it problems in your book. You can choose which ones you want to submit, but you should submit either all the try-its from the textbook that I state in there to do, or you could submit all the video examples and the ones I leave for you to do as well. But you really should be both reading and watching the videos. So plotting points. Number 1, graph the following points. Name the quadrant in which the following points are located. If the point is on an axis, name the axis. So in your textbook, there is a figure that labels out the quadrants. It's also here on your right. There's a grid, and in the upper right is quadrant 1. In the upper left is quadrant 2. Underneath that, in the lower left corner is quadrant 3. Lower right corner is quadrant 4, and we're using Roman numerals. The x-axis is the horizontal axis. Y-axis is the vertical axis. If a point falls on an axis, you would just label it as such, that it's, whichever axis it falls on. So the first point that we're going to do is -3, -4 in parentheses. So that's A, point A. So we would kind of hover over the origin here. I have a grid with 5 units in every direction. So I'm hovering my pen over the 0, and then I'm going to move 3 units to the left, but I'm not going to plot anything yet because my Y, my vertical change, is -4. So I want to go over to that -3 and then down 1, 2, 3, 4 units and plot that point. So that is point A, and I'm going to label that there. And the quadrant that is in is quadrant 3. So quadrant 3 will always have negative for sign. So I'm writing that off to the left with parentheses around it. Negative, comma, negative. The next point we have is B, and that is in parentheses -5, 0, or comma 0. And so that one, again, I'm going to hover over the 0, and then I'm going to just move 5 units to the left. There's no vertical change, so I'm just going to plot the point there. Again, this really should be reviewed, but I'm just refreshing for you, especially with the quadrant naming. The quadrant that is in, we would just say x-axis. And for point C, we have in parentheses 1, -4. So now I'm going to hover at 0. I'm going to move to the right 1 unit on the x-axis, and then I'm going to move down 4 units to represent that -4 for the Y, and that is point C, and that is in quadrant 4. And if we were to write how the signs go, we would have a positive for the X and a negative for the Y. So I'm just writing parentheses plus comma and a negative sign with parentheses. D is the point -2, 7. So that one, again, I'm going to hover at the 0. I'm going to move -2 units to the left, and then I'm going to go up 7. And you'll notice here that although my grid just goes to 5, I can kind of extend off, just judge. So if you run out of grid, just kind of judge where it might be, and that's point D. And that one is in quadrant 2. And that is also a negative. E is 0, -3. So that is on the y-axis. So I have no horizontal movement there from the origin. I'm just going to go down 3 units. And that is, I'm going to label that as E. And that's also in quadrant 4 that we've seen before. So for our quadrants, the first quadrant, again, that would be plus plus. Our quadrant 2, it kind of goes counterclockwise really, is negative. And then quadrant 3 in the lower left is, oh, sorry, I wrote that wrong. Not negative, it's a negative plus for quadrant 2. I'll fix that. And then quadrant 3 is negative, and quadrant 4 is plus negative. So you'll have some brief practice with that in the electronic homework and maybe the paper homework. We're going to do one here, finding X and Y intercepts, and I'm going to show you just, some quick methods to do that as well. It's pretty common to plot a line this way. So given an equation, find the intercepts. Find the x-intercept by setting y equal to 0 and solving for x. Find the y-intercept by setting x equal to 0 and solving for y. So number 2 here is find the x and y intercepts. Give your answer as coordinates. Then graph the straight line based on those 2 coordinates. So we want it as a coordinate pair. A lot of times students will just write x is 2, like they don't typically write x-intercept is 2, but we would want to write 2, 0 to represent the x-intercept, and say the y-intercept, for instance, if it were 5, sometimes people just write that as 5, but it's specifically 5 when x is 0, so it's the point 0, 5. So be careful of that labeling. If you were to say the y-intercept is 5 and be real clear about it, that's okay. But for now, I want you to get in the practice of writing it as a pair. A lot of professors require that too. So we have 4x minus 3y equals 12. So sometimes I like to just set up kind of like a little tic-tac-toe board. It looks like I make a T, and then I have x and y at the top, and I just, if I want to find the x-intercept, I'm going to set y equal to 0. So let y equal to 0 and then find x. So I'm going to plug that in for my y. So I have 4x minus 3 times 0 equals 12. And now I'm going to solve for x. You can pretty much do that in your head usually for these, if they work out nicely with minimal mess and fractions. So then I would have 4x equals 12, and then divide both sides by 4, I get x equals 3. So right away I'm going to go put that in the table so that I'm tracking where that 3 goes, which y it goes with. And then I will write over here the x-intercept, and then put a colon there is the point, and I have a parenthesis, 3, 0, end parenthesis. Now I'm going to go find the Y-intercept. So I'm going to plug 0 in for X. So I put 0 in my little T chart for X in the X column. That's why sometimes it looks like a little bit like tic-tac-toe with those O's there, or zeros. So now I'm going to let X equal 0 and find Y. And I would just plug in, as I did before, 4 times 0 minus 3Y equals 12. And the 4 times 0 goes to 0. Be careful on this when it's a negative there, like we have. Bring the negative down. Sometimes people forget. It gets kind of lost. So now I have negative 3y equals 12. Divide both sides by negative 3. And I would get y equals negative 4. And that, again, that's only for the intercept. So you need to clearly mark that in your chart. Put that negative 4 right up there in the y column next to the 0 for x. And then I'm going to write y-intercept colon parentheses 0 negative 4. So now once I have these, I can plot them and connect the dots. So I have my x-intercept. I'm going to plot the point 3, 0. And then I'm going to plot the y-intercept at 0, negative 4. And I'm going to go ahead and connect the dots. You would use a straight edge. I don't have one in this app. Make sure you extend across both axes and include arrows unless you have some kind of boundary or like a domain that stops you from extending, but this will go on to infinity. Also label your points. So we're going to have put the point label right next to the dot. So 3, 0. And label it x-int, and then the y-intercept, put parentheses 0 comma negative 4, and label y-int. And that's it for plotting using the intercept method. One quick way you can actually do this, if you like, is to do it kind of in your head. So I call it the cover-up method, or intercept method. You might have seen this before, but if you notice that in this 4x minus 3y equals 12, the 4 and the 3 divide nicely into 12. So if I were to put 0 in for y and find the x-intercept, like that kind of blocks that out. And you can think 4 times what equals 12? Well, it's just 3. So it's kind of easy to figure out that way. Then you can also do it for the other one. So if I had x equal to 0, it basically just blots that out, and you think negative 3y equals 12, and so you can just put in negative 4 and kind of just do it in your head. Thanks for watching. Have a great day. I'll get 2.2 going in a minute.